Finishing times for the second exam in my STA 3123 class are normally distributed. The second exam for STA 3123, Stats 2, has historically taken 86.56 minutes on average for students to complete. The standard deviation is 29.03 minutes. What percent of the class will finish before the 120-minute time limit? Okay, so in this problem it says, first of all, that the grades are normally distributed, right? Or finishing times, I should say, are normally distributed. So we're thinking bell curve. The next thing is they're looking for a probability, or what percent of the class will finish before 120 minutes. So let's go ahead and draw our bell curve, labeling the information that was given to us in that problem. So we're going to draw the bell curve. We're going to record the mean that they gave us in the problem and the standard deviation. Now when we look at the problem, it said that the mean was 86.56 and that the standard deviation was 29.03. Now I'm going to label the x-axis at the bottom here. Since we're going to be using the calculator to do this problem, I'm going to label the x-axis with the mean of 86.56 on the curve there. Now it says what percent of the class will finish before the 120-minute time limit. Well, 120 minutes would be here, right? So if I want to know what percent of the class will finish before that time limit, well, before means below that time limit, right? So we're looking for this. What percent of the class will finish the exam somewhere earlier than the 120 minutes? So I've shaded the area I'm looking for. I have my x-axis labeled with my mean and my right bound of the shaded area. So what my calculator needs from me is where the left bound begins. In other words, where does this shaded area start? Well, it starts over here at negative 10 to the infinity, or negative 10 to the 99th power, right? So in other words, the shaded area starts at negative infinity, and so we're looking for negative 10 to the 99 in our graphing calculator to represent that negative infinity value. Then our right bound, where it ends, is 120. So we're going to call this the left number for the interval. This is the right number for the interval. And then we have the mean and the standard deviation. And that's all we need for our calculator. So remember, we're going to press second and vars to get to our screen, right? So second, then vars, and then you're going to do option 2, normal CDF. Now, once you're in the normal CDF option, you're going to put in the left number, then the right number, the mean, and the standard deviation. So that's how we have to use our calculator. So let's do that now. Here's my graphing calculator, and we're going to go ahead and do just what we said. We're going to press second, so let's turn it on first. We'll press second vars, take option 2, and then now that we're in there, we're going to give it our left number, which was negative 10 to the 99, so negative 10 to the 99th power, comma, the right number of our shaded area, which is 120, comma, the mean, which is 86.56, comma, the standard deviation, which is 29.03. Close all that up, hit enter, and we get our final result. The answer is 87.53%. So 87.53% is the solution.